my God, it just worked on the first try now. Amazing. Of course it's not. Oh, there we go. Okay. Worked on the first try. Pew, pew. So, this. Am I plugged in? Yes, I am plugged in. I'm going to just turn up the volume on my mic a little bit. Is that insane? The thing is if I do it up all the way, it clips, and that is not the best. What? Oh. No, 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 my friend. Why is it? God damn it, YouTube. It says it's private. It's doing this again. It's set it private. Can't unset. Just a second. I'm trying to figure out what the hell. Okay, why are you private? Just go. Unbelievable. I swear to God. If it ain't one thing, it's another. Okay. So, intertwingler. Yeah, why? Whatever, dude. Intertwingler. Here's the website for Intertwingler. It is incredibly bare bones. Intertwingler is a piece of infrastructure. It is kind of occupies the same space, I'd say, maybe as. It's hard to say. Like, it's WordPress maybe, but like it's nothing like WordPress. It's kind of like it's like more. It's got more going on, or not. It's got different stuff going on. Let's just say. It is not a sprawling behemoth like WordPress. It is a very small piece of software. Just gonna get my coffee. I have discovered, I should say, I'm Columbusing here, is that when you only push down the plunger on a French press a little bit, you actually get the friggin' crema instead of having it all stick to the inside of the damn thing. And of course, people used to try to get rid of crema anyway. But, so yeah, intertwingler. It's a piece of infrastructure. You use it to make websites. A French press live stream. Oops, that's not what I wanted. That's not what I wanted either. US1. No. that U, no, guy, okay, U. Control U1 SO, that goes to number 1. But we want to go to the code, or do we want to go to the drawing? Ooh. Did I bust off the lead on the pencil? No, I did not. Okay. Let me just draw a drawing of like what the architecture of intertwingler looks like. I've done this like a million freaking times and a million freaking streams, and it's always the same. I think the best way to draw it is to draw it as the process of a request or sort of response loop, and I'm going to do this from memory, but you know, it's so well rehearsed I can just do it forever. What is that? Why is everything annoying me right now? Oh, that is just nothing. Okay. All right. Whatever. Okay. So, you know, typically HTTP requests, they will, you got your user. I'm going to make him cringe face. Whatever. I can actually draw, I just don't anymore. So they make a request. Let me remember how this works. The request gets, like, so the address gets manipulated. Get some stuff, sort of gets canonicalized, whatever. Then the request goes through a set of queues. You know what? I just remembered. I don't have to draw this because I already did. What? Where's my fonts? Oh, you know what? I know where the fonts are. It's the friggin'... So, it's Snap. Snap does not have the permissions to see the fonts, that's why. Goddamn junk. Okay. So, this is what's happening. User makes a request, you get URI preprocessing. That's what this piece called the resolver. That was a hard thing to do. Then there's this request transforms. Those manipulate the actual request and the request headers and body. Then the request gets passed to a request dispatcher, which selects a response handler. And then the actual, like, where the data and whatever is stored or whatever is going on with the request is off. So outside of the zone here this is the web part, the intertwingler engine. So the response handlers, you know, it picks a response handler. It sends that back to the dispatcher, which then pushes it through the into this response transform queue. So these request transforms and response transforms, these are the parts that haven't been done yet. And these can be manipulated. So like any part of any queue after the current queue can have stuff added to it, basically. And so, and then the thing is there's usually, I mean, there can be as many queues on request and response as you want. But typically it won't make sense to have more than one on the request Although on the response queues, you'll probably want at least, well, you'll probably want 3. So you got the early queue that is like all of the things that need to happen before subsequent manipulations happen. And then the response gets passed to the next queue. So then there's this addressable queue, this sort of idea of an addressable queue. And that is for actual manipulations that can be addressed directly as URL parameters. So you can see there's this little line that goes from the pre-processing down to the addressable queue. And then you have the main queue after that, which is the whatever your sort of stock transformations are. So that it could be like gzip the response, or change a PNG into a WebP, or like stuff like that. So the idea was that there's this idea of handlers in intertwingler, and a handler is just a microservice that responds to certain addresses with certain request methods and certain addresses. It sort of the sort of handler bundles those up. And the idea with that is that you could, write these simple handlers, and then the transforms themselves are handlers. And well, you'll sort of more like the transforms would live in a handler. So anyway, so the individual transforms, would be like individual resources in the microservice, like individual targets, endpoints, whatever you want to call them. Although the actual microservice itself, like the actual code itself, might bundle more than one. But I mean, in order to be a handler, you need to have like at least one address and at least one, responds to at least one request method. And the so interestingly, so I sort of got this idea from what did I get the idea from? I got the idea from a couple. There's a couple places where I got the idea from for this exact design. One is Apache, obviously. So this is Apache works like this. Another is Cocoon is this thing from like eons ago. It's this web framework, and there's another thing called NetKernel that's like almost the same vintage. It's about 20 years old now. Cocoon is older than that. It's like 25 years old. And the idea is you have these kind of, you have this idea of like pipes with types, basically. So whereas like Unix is like you can have pipes and filters that operate over byte streams, intertwingler has got kind of like pipes that will operate over like messages. And I get that idea from Fielding's PhD dissertation, the REST dissertation. So intertwingler is kind of an embodiment of all of that. And the whole idea behind it has to do with being able to target these little boxes as individual development targets. And then they're like very, very, very well defined. And then furthermore, like you can sort of orthogonalize a lot of the overhead because, if like a transform will just operate over the body of a request or a response, and you can cheat it. There's a sort of way to cheat. Now, cheat it if you want to be able to manipulate the entire thing. So it turns out, there's this interesting little feature of the fast CGI protocol that like not a lot of people I think are aware of, which is you basically give it a mode, and the mode So the regular mode is content. It behaves like fast CGI. It just takes a CGI script, puts it in a loop. It's got a binary protocol for sort of abridging the overhead of putting multiple requests through this loop. And the idea behind fast CGI, of course, is that you fire up the script once, it's sitting on a socket, and then you just chuck, request after request into it, and response after response comes out. Otherwise, it's the same as CGI. So you can just take a CGI script, stick it in fast CGI. It's a fast CGI script now, more or less. And I think there's more or less like Python's WSGI, and there's a thing called SCGI, and there's a couple other sort of similar things where it basically is CGI, except it's got this extra bit where you're running in a loop. And so this has sort of been superseded by, why not just do HTTP? And, we'll just reverse proxy, we'll do HTTP, and don't screw around with, changing protocols to CGI. We'll just do, we can just do HTTP. So that's sort of the maturation of that idea. And I was like, well, these alternate modes of fast CGI, like one of them was like authorizer, and another one was filter. And I was like, well, hey, and of course, there are fast CGI, one of the things that I did, the little forget passwords, passwordless authentication module that I do is a fast CGI authorizer module. And if you you bolt it into mod authns, FCGI, you can use it on a web server that's like not using fast CGI for anything else. It'll just work. And so I was like, well, if we've got that capability, well, why don't we do more stuff like that, and then take it out, blow it out to the sort of HTTP, reverse proxy level, and then you've got all of these little thingies are just these little tiny microservices that all they do is respond to a certain set of URLs with a certain set of request methods. And then the transforms are just more of these things. So all you ever have to write are handlers. And so that's the sort of crux. What I got to make is I got to make all the stuff that is not that. That's the job. I've got to make this sort of request transform. How does it get it out of the database? And how does it set itself up? And what does it do to dispatch? And how does it organize the data structure? I got to do all of that. And that was all that was left when I detoured in early December to work on some other sort of, I don't say emergency exactly, but let's just say it was a special request. I was going to continue with the modeling of that. I'll show you what that looks like. Yeah. So, heck, I can even go through that right now because it's this is the updated tool. The old one looks like this. Got rid of that. I'll just go quickly through it because it's fun. So yeah, this thing is called the IBIS tool. It's called App IBIS. IBIS is a thing from the 70s. Some management consultants came up with. I don't know if they're management consultants or if they were they were academics. But it's kind of hard to say where the academic stops and the management consultant starts with that kind of thing. Anyway, so there's a vocabulary called SCOS. It refers to Simple Knowledge Organization System. And you use SCOS to make concepts. And the concepts, we're just talking about concepts. We're talking about ideas, typically words and stuff. I mean, a concept in that word is not the same thing. You can have the same concept in multiple words for it. You can have multiple concepts with the same word for it. So, it's not exactly congruent. But the idea behind SCOS and concept, IBIS, you know what? If you go to, I'm just going to type it into the chat. IBIS, we have issues. That should do it. Let me just double check here that works. Yes, it does. Might have blown away. Oh no, I didn't even blow away the CSS. Anyway, so IBIS. So, let's take the trip down memory lane, back to, I don't know, 2010, 11, 12, something like that. I designed a vocab for representing IBIS. I do it on top of SCOS. And the reason why is because the entities in IBIS are kind of like entities in, they're kind of like concepts anyway. So really, really simple. There's 3 kinds of entities in IBIS. There is an issue. So the red guys are issues. They are a thing in the world that you want to do something about, or either if you don't want to do something about it, or you can't do something about it, you got to steer around it. It's it's an issue. It's as you would think, there's an issue with whatever, a problem, something yes. So, 3 kinds of thing. Issue, positions, arguments. An issue is a thing in the world. You either want to do something about it or you can't. You got to steer around it. A position is what, if anything, to do about it. And the argument is why or why not. And so, yeah, back in, what did I actually say for the date on this thing? So this says 2012, and I don't actually think that's the oldest date on it, but we'll just say it was 2012. So just to quickly run through this. So the issue was the client wanted a version of the IBIS tool with just the SCOS interface. So just the SCOS interface looks like this. You've got concept. This is for making, SCOS is for making concept schemes. And a concept scheme is like glossary, thesaurus, index, that kind of thing. That's what SCOS is for. And so 2013, I made this tool mainly for representing IBIS. It did not have this graph on it. But then very promptly after that, I chucked, I just sort of cut and pasted it, and I made a SCOS version as well because it turned out to be useful. Now, when I made this, it had there were some sort of principles about it that were goofy, but I'm going to go through the reasoning, because what this does is this captures design rationale. The whole point of IBIS is it captures why you're doing stuff. And so when I say this is the origin, this is the origin point, the client wants a version of an IBIS tool with just the SCOS interface. Okay, fine. Response, make a cut of the tool that disables the IBIS functionality. That's what he wants, that's what you get. Okay, well, supported by, here's an argument for why. This is at least superficially the simplest strategy. Well, it's been opposed by, you're going to have to maintain a branch of the software you want to retire for who knows how long. So that's a no-no. Fine. So we go back here and we're like, okay, well, How about this other thing, which is overhaul the UI of both IBIS and SCOS interfaces so they behave the same? Oh, right, that's another thing. Okay, well, I actually didn't make an argument for that. And actually go back to here, and I'm going to say, go to this and say, Palantir level shit. Have you ever seen how like Palantir? Think about Palantir is like it didn't actually work when they sold it, and then they got the money, and then they made it actually work. That's how Palantir worked. But this is, yeah. So you can see when you go through, you can see, well, this suggests another issue, and the issue is, well, the SCOS interface was knocked together very hastily and is awkward to use. And actually, this is the reason, well, whatever. So fine, fix the JavaScript in the SCOS interface so it works properly. Well, the whole reason why the SCOS interface was awkward is that fixing it would have entailed overhauling the IBIS interface too. Fine. Overhaul the JavaScript on the IBIS interface so it's sufficiently generic to accommodate the SCOS interface. Well, this will entail work on the server side as well as overhauling the SCSS. But also, like, the IBIS interface was never very good, and the SCOS interface is worse. So, like, why would you, like, put all of this effort into a tool that you want to get rid of? I want to get rid of this tool, and spend all this time and then have to maintain a branch just for one client to use. So anyway, you get the idea. Like the whole point of this, like what the thing that you want at the end is you want you want like a set of actionables. You want like a sequence, or more like a tree of actionables, because that's going to tell you like what the actual scope is, like what you've actually kind of decided. Now, what this is just like when I'm decided I'm not going to try to fill this out anymore right now. I was going to come back and fill it out some more, but like I think that since the job of this is done, like it doesn't make any sense for me at the moment to relitigate it other than to have it as a demo like this. So I am going to go back to actual intertwingler itself. Now, what I will say about this though, and what I ended up doing, and I didn't write this down yet, is that what I ended up doing was like I bifurcated the front end and the back end so that the front end can get just cleft right off and like stuck onto intertwingler without any changes. And really the ultimate problem with this was that it was this IBIS tool was that it was so sclerotic that it took a lot of effort to add in, like, just if I wanted to add stuff to it, I just couldn't. It's just too much effort. So, there's like directions that I want to take this tool, but I just can't because the back end, the server side is just not up to it. But what I ended up doing over the course of December was effectively like carve it down the middle so that I can just jettison the server side and I can keep the client side, and I can just take that and put it on intertwingler when once I get it to work. And so that's sort of what I need to figure out. So this. So what I got to do is figure out at this juncture how much work, and this is always the fun part. Maybe I will go back to this IBIS tool. You know what I'm going to do? I'm actually going to dump it. Where are we here? Because I don't have the infra right now to. Well, yeah. You can see my little secret. So I should just remark that the whole point of this tool was to road test this protocol that I designed, which embeds RDF statements directly into what's it called? Embed RDF statements into the into standard HTML forms, which is like I had this like whole like no JavaScript thing going on. Anyway, so all of the data, like it is 100% transparent. All the data is 100% transparent. So, meaning that like every like jot of state data has an address. Just these UUIDs get transformed into HTTP URLs. It's not very sophisticated. And you can just grab that. I'm going to save that. This is my Linux, so I'm just going to save that now. TTL 2004 01 24 dope. Should have said IBIS dump, but whatever. And then I'm going to just like go over to the shell and just nuke this thing. Oops. Curl-x, delete. Okay, so you're dead. If I go back here, this is going to be empty. Bye. Yep. Okay. You can actually see the reinitialization part. We'll call it, I mean, the space doesn't even need a name, but whatever. I'll just say testy. Let's call it the liminal space. Why not? We'll call it NHG network, new focus. I need to make UI for this. Because I think it would be what I just did when I like nuked the entire thing. Like, it would be useful just to like spin up a new thing in it. It's just yet another freaking detail I don't want to think about right now. Name of new focus is this will be intertwingler workspace, whatever. We should also collapse that too. It's fine. So, intertwingler should process and run. This can be anything, honestly. Intertwingler should process and run transforms. Okay. One thing I did get rid of, because I don't really know how I want to add them back yet, is, well, I mean, I want to be able to have external links. I should remark that there have been a ton of IBIS tools. So like the original IBIS was done on index cards. It was analog. It was also collaborative. This thing is effectively solo at the moment. Like you can't really see, I mean, I don't surface any of the multi-user potential for it. It's in the data spec, but I haven't implemented it in this thing. But it's fine because it's such a pain in the ass to do it like on top of this backend. It'll be easier to do with intertwingler because I can just Well, it's just stupidly easier to do with intertwingler. That's the whole point of it. So, intertwingler should process and run transforms. Yes, it should. Cool. Well, let's implement that. I'm just going to leave that for a second. So an issue. The other thing that I should remark about is that like the language of these, like having like too much value language is more of a position-y thing than an issue thing, but like I'm not gonna sweat it at the moment. Anyway, where are we here? Okay, I'm gonna leave that for a second and let's just go and look at the actual code. So, like I said, so the engine, if I go here, there's like, sort of like this CLI harness. And the harness has multiple engines. I've like forgotten how to draw E2, E3, whatever. Then these will have like a layer of let's just call them handlers, like kind of like a pool of them, so we could imagine that being multiples. So these could like all point in that. And then the transforms. Again, the transform stuff, again, these can like all point to the transforms. There's like multiple transforms. The transforms are just handlers, so the transforms will actually point to the handlers too. And then finally, there is the like params. Actually, we can just put, again, there's multiple params. The handlers can use them. The transforms can use them. I made this thing, this parameter registry. So the thing that I didn't like and I was really annoyed by was like the fact that like you know, like query string parameters and stuff, like organizations, like you could not control that vocabulary, and so like that would get into the URL, like that's just how it would be, and like this thing will have a hyphen and that thing will have an underscore, and it's just nothing you can do about it. And so I made this basically you've got a controlled vocabulary of parameters that name parameters and their cardinalities and their data types, because like this is sort of one of those things that you would really benefit from orthogonalizing if you wanted to have an engine. The engine takes care of like input sanitation, passes it downstream. Whatever your downstream doesn't have to do nearly as much checking because it's already checked. And furthermore, it's if you really didn't trust the input, like if something happened to it between those 2 points, you know, you could just load up the parameter registry in that code and check it again if you wanted to. So the engine. So one of the things that I'm doing is I've got this kind of like self.configure thing going on. And there's a sort of idiom that kind of runs through the entire thing. And so if you're not familiar with Ruby, and then I can talk about why I wrote this in Ruby, you know, aside from it being like a reasonably okay language to write in. Ruby is one of the few languages that isn't Java that actually has like a piece of infrastructure that I needed in order to make this damn thing. So Ruby it is. It's either Ruby or Java. Surprisingly, Python does not have one. Reasoner is what they're called, the piece that's missing. Ruby does. And it's not the best, but it is, it's effective enough for what I need to do, whereas Python doesn't have it at all. So I would have to go, if I wanted to write this in Python, I have to go and write a reasoner. So, yeah, anyway. I actually prefer Ruby to Python anyway, so, because Python is incredibly pedantic. But anyway, I digress. So, you can see these things. So this is basically what I said. Oops. So params, handlers, transforms. If I go here, oops, you can see params, dispatcher. The dispatcher is the thing that manages the handlers. And I'm actually wondering if I need to. So I'm using words like harness and dispatcher and stuff. I'm gonna have to clean up the language on that so that people aren't confused. But not today. Anyway. Now I'm kind of wondering if I want to I don't know. I'm just looking at this as the other things. These are constructors. They are not these sort of go get stuff out of the graph. So like one of the issues is how does it get its configuration out of the graph? So we can actually go back here and we can say question by how is the engine going to get the information configuration. We made a line. And the response to that is we have a static method. So basically the difference between like the regular constructor and this configure method is that the configure method actually configures it, whereas the constructor only just pulls out. It just initializes an empty one. So that's just the difference between that. I would say that another issue, though, that this questions is what, in fact, are we getting out of the graph? And then, like, what kind of structure are we turning the configuration information into? This was funny. You work on this and you get these structures and you're like, ooh. You're like, where? Like, I haven't done this sort of. This is like this sort of why? You know, like you get like a 3-year-old or something like that, asking why over and over again. It's kind of like that, but except it's not why. But You could do it for that though. I've used the IBIS tool for things like helping somebody understand a collective bargain. So it's pretty versatile. I mean, this is the thing. It's not just for making software. That's like kind of the thing about it. The reason why, like, again, like the original was done on index cards in the 60s, 70s. Somebody digitized it in the 80s, 88. And the thing is he did it on Spark stations. So, you know, like whatever they would have been, $10,000, $20,000 a piece at the time. You know, and that would have been a local lab. So, you know, it would run at his university, but it wouldn't run anywhere else. And subsequent systems that implement IBIS are very sort of hermetically sealed. And like part of the actual, one of the shortcomings of this particular thing, implementation is it's also kind of, it's not as bad because everything is directly addressable. But it's not as permeable as I would like it to be. Like I would like to be able to like intersperse the IBIS tool with like other web content, like be able to sort of mix it in together. And it's just not very good at that. I mean, it's just, it's sort of like, there's this sort of invisible wall between it and other stuff. Intertwingler fully has the capability of mixing content together. So, because intertwingler works based on like what the stuff is, not like where it is in URL wise. It's like what it is in the database. So anyway, let's get back to the code. So actually, like, so the transform harness, and again, there's two things called a harness. There's the engine harness and the transform harness. With the transform harness, it is the thing that, so it's not here, but like you would imagine there's sort of an imaginary line around the transform queues. That's where the harness lives. In fact, I would add that if I wasn't lazy. But anyway, so that's where that goes. The dispatcher's already in there. The dispatcher is a very naive algorithm that picks the handlers. That's another thing that we've got to do. So we can actually say that the, where are we here? The dispatcher is currently not equipped. So this is suggests the issue that the dispatcher, oops, not equipped. To handle to present complex descriptions, handler selection criteria. Just drawing pictures. Okay. So One of the things that I would like to do is like also a sort of status change thing. Like the thing about that is like obviously if your stuff is sensitive to like if a issue is resolved, like you don't just mark it resolved, you actually like stamp when it was resolved. And like who resolved it and all that kind of stuff. So it's not just like a bit. So it's kind of like what are called inference rules. You would want to be able to generate that. Like you want to be able to say like, if it has a, resolved event attached to it that it does not have a de-resolved event, or status change event that takes it away from resolved, that has a later timestamp, then like make this statement make there be a result. Now, I don't have that capability yet. I mean, I think what I'm going to end up doing is probably end up like designing my own graph database because that's where we're at. Just because there's sort of like useful stuff. I think like part of the reason why like RDF tech like didn't get as much uptake as it did is because like it's so abstract that like it's like it's really hard to like demand pull anything because it's like so hard to get bootstrapped that you're like, I didn't get to the point where I decided that I needed a thing. So that thing there was never any demand for it. Like just sort of when you contrast the sort of the paucity of reasoners out there, and like literally there's like 30 zillion for Java and like one for Ruby and like one for Common Lisp or something like whatever, and nothing else, and you're kind of like, okay, like where, and of course, reasoners are not all created equal. There's forward chaining and there's backward chaining, and there's like the ones that like puff out all of the inference rules, like they puff out all of the statements that are sort of inferred from asserted ones, and then you get like a bazillion statements, which is untenable, and it takes forever to run. So that's no good. But you sort of want to be able to say, like, you want to be able to like, infer, like, if this thing here, there's a rule for that, well, then there's another thing there when you want to see it, but not for everything all the time. Anyway. So we've got, this is the engine. And then we have the transforms. Oh, excusez-moi. And the transforms, so there's like, let's just look at the, oh, this is already here. Did I do this already? Maybe I did. Maybe that's what this is. No. Okay. So, the transform represents the metadata associated with it, the function, the actual implementation. And it belongs to queues. It has events. So this is the other thing. I've got to implement the trigger events, so that's got to go on here. There is no side of the code of trigger events. So that's another thing that's gotta have something attached to it. Oh my god. I find I get so freaking tired in the afternoon, like around 4 o'clock and change. Today I am trying to buoy myself by consuming a unwise quantity of coffee. We'll see if I actually manage to sleep later. I mean, it's kind of one of those things where like I'm so freaking tired that because I go and I swim, right? So I'm so tired by the time I get like 4:30 comes around, I'm like falling asleep in my chair. And so normally when I try to do this kind of thing in the afternoon, I'm like, I gotta go. So I'm like reasonably all right now, so that's good. I'm gonna keep going. We can kind of see how this is like shaping up. Like it's kind of like a to-do list, but it's like got a structure. It's got like dependencies, and like other stuff does this, but it's like to-do lists. Sometimes there's more than one dependency. Like that kind of thing happens. Part of the reason for this is it's got a structure that's not just a strict tree. It's a tree right now, mind you. Transformation. Okay. So we've got to come up with a data structure that can manage all of this. How's the engine going to get? So we're going to respond to this. First of all, we're going to say, create a pattern. We love patterns. For all classes that retrieve such that self dot constructor merely but the class method self.configure. Let's call it configure. Actually pulls in graph data. To do some code. Oh, there's a bunch of hey. That's a lot of junk. Okay, let's do this. Treat the graph data such that the constructor merely initializes the object, but the class method configure actually populates it. Ain't nobody watching, so I'm just gonna screw around. Unless the meter thing is wrong. Nope. Okay, we're back. Yeah. Oh, now there's somebody on YouTube. Wow. Everybody was on Twitch before. Well, you know, I got a multiplexer, so I stream on both at the same time. Anyway. Actually, where was I here? So, we are trying to determine what anything is. So I am filling out the content on this bad boy. Why does that not fit? Whatever. So we already know, well, sort of like what there is the TFO ontology. Well, that's also what factor are we getting out of the graph? So, well, whatever. Let's just go back to the code. Effectively, like, so the engine is a handler. And the transforms are handlers. Everything is a handler in intertwingler. And a handler, again, it's just a microservice. It's got little pieces on it it's got like stuff to be less dumb about life. But anyways, you can actually see if you go, where are we here? We go back to this diagram. You can actually see in the code, when I go back to the code, so this like split PP resolver URI4, so that is this. And then this down here is, so this will rerun write the request, maybe. Then this dispatches to the actual handler, which if you go and you look at that, which this hasn't been. So this is sort of the problem here, is that this does not have what it needs in order to do what it needs to do. So we're sort of like trying to figure that out right now. Trying to figure out what it needs to have. Ideally, and this is the other thing too that I'm going to need to clean up is like exceptions. So I had this like brain genius idea that you could have exceptions that were actually like HTTP responses, and then you could just like blast out of whatever you were doing, and then you would actually have like context sensitive. And I mean I'm not saying this is original. Other stuff absolutely does this. So, but like it's not. It's like it's so not organized. It is. It's all over the freaking place, and so like I've got to like get all that under control, because like sometimes, for example, it returns a response as opposed to accepting it. So like, you know, is that what we want to do policy wise? I don't know. Well, in this case, it's in a rescue, so whatever, maybe not. But what I'm trying to figure out at the moment is, like, we don't need that anymore because we discovered that we actually had a diagram. We didn't have to write a crappy version of the same diagram, because you could just go to the diagram. So there's one thing that I have not discussed in this, and that the dispatcher holds all of the handlers. Well, it doesn't matter what they are, except of course the engine itself. So the dispatcher's inside the engine. The dispatcher holds all of the handlers. And so, and then of course, like all of the transforms are themselves handlers. But again, the queues and crap are all they're all in the graph. Like all of the, and I can actually show you what that looks like. I think this is it. So this I thought was clever. I made a URN resolver that will pick up these URN X Ruby blah 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 blah. So it's like URN X Ruby intertwingler handler file system semicolon. So that's like the thing to load, and then the constant. And of course, this URI resolver does not care what the constant is. It doesn't even care necessarily that it's a constant, but it's just a symbol in there. It could be something else. But that's what it's looking for. And then this like question equals, that's a URN thing. I really wanted to just have like an X-Ruby URI scheme rather than going URN, but the Ruby URI module has gone and done something silly with, it sets a constant, and the constant can't have a hyphen. And so it's going to be like, yeah, anyway. URLs can have all sorts of characters in them. I think they can have dots, they can have hyphens, they can have plus. I don't remember what else they can have. I don't think they can have underscores of all things. But bottom line is you're going to have these like namespace collision potential. You don't need to set. I mean, I filed a bug. I haven't seen any movement on it though. So, but the URI, the URN module absolutely can do that. So I decided that it wouldn't be an expedient. So bottom line is you've got these URIs. You can specify configuration information of the actual like class to load and what have you. So that's how those get loaded. You got these queues. And you got the resolver. And this has all of the configuration information for that. It's got, does it have the, it does not, fragment, listen there, document. Oh, what am I saying? That's the resolver. This is the engine. So the engine specifies handlers. It's got a list of them, so those get loaded in order, which is not guaranteed in RDF. I mean, just don't try to rely on that, on things going in order, unless you have a specific explicit list. Big no-no. It's one of the things that the people doing vanilla JSON kind of forget. There's reasons for that. Whether you can agree or disagree about whether they're good reasons doesn't make them any less of a reason. So, where are we here? So you can see, like, this is a schwackadoo of configuration. These are the transforms themselves. And they have like these accepts, returns, got the implementation in there. I don't remember. I actually have to like review. So I went and I did a bundle in here. No, I don't have a bundle. But let's actually look at the, so I made like a vocab just for intertwingler. Let's actually look at that. Because I completely don't remember. Is there like a bundle in here? Yes, it is. Okay. What else is going on? Sure. Okay. So this might actually be wrong now. Oh no, wait, ITCV transform, not TFO transform. Didn't I change that? This is how the sausage gets made, by the way. Vocabs transformation dot.xml. Boop, boop. Hello? Hello? There we go. So we got the bundle in there. Transform TFO. Oh my god. I did change it. I just didn't. Because did I seriously? Okay, let's just push D clients me vocabs transform diff. Let's go look at it now. You're not it. You are. Yeah. That's not changed though. Classes dot. This is like normal though, like when you're doing like RDF stuff, you got to bounce around between a bunch of different things. This is my whole shtick. Function. Functino. Transform. Transform. Function. 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 Prob entity? Is it? Yes, it is. Of course it is. Function. Why didn't I do this before? Function. Function. Oh. Function to function. Did I change that to? Okay. Properties dot. Function. 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 Can't remember why. No, I mean I do remember just can't remember why I just didn't finish this. Function. Maybe I actually wanted to call that function list. What do you think? Oh yeah, I definitely call it a function list. I think okay. That's annoying. I could have just done that all along. Just in there. Now the annoying thing is I'm gonna have to regenerate. Transformation function. Markup transform. It's funny, you can like see my elbow. Like right there. Anyway. So when you go back to, this is intertwingler here, just running the old documentation server. I want to, it's probably gonna blow up, but that's fine. I want to actually go here. Rake files, a rake file. Is it in the rake file? This I need to organize a little better. Because I need to go to scratch. Okay, I got to. Like, it's dumb that I have to do this on the command line when like there's actually like a module interface that could just like do it code-wise and just work. But transformation, TFO, TFO, transformation. I'm gonna go back to the, oop, that's not you. Boop. Okay, now we gotta go here, we gotta TFO. Here. Actually, ooh. TFO class. Yeah, we want it there, and we want to get another one. I should actually just do this. Let's get CI. Why not? And then we gotta go here. Oh, you were there? Actually, yes. This is where I want it. Do I? Absolutely it is. Except it's not CI. It's TFO. See what I did there? Okay, let's just look at the get def. It's a bunch of shit. That's not what I'm interested in. Bundle function list. And it absolutely looks like TFL insertion has been correctly superseded. Whole schwackadoo of stuff in there. It's fine. Yeah, all right. Good. And I guess I can commit it. Status. I mean, TFO. Should probably do the ITCV one too. Oop. Actually, this is like look over ITCV. Did I do that? TFO bundle. Right. This can just go away. This disclaimer. Yeah, so, well, you don't have to. There's like nothing super consequential in here. It should import it though, which it probably does. Let's take a look. Yes, it does. So we want like a unidirectional sense of like where the stuff is imported, like where the more generic to the more specific, and the TFO stuff is more, the transformation function stuff is more generic than the intertwingler specific vocab. So presumably you could use the transformation stuff elsewhere. Maybe not, though. I don't know. So we'll just kill that for now. Kill that for now. Kill that. Oops. Kill that. Don't ever need to look at that right now. Not don't ever need to look at it, but we don't need to look at it right now. We can also fire this up again. I wish I had like, I don't have like best practices for these splat parameters. Anyway, it's fine. So that is done. But you know what's probably not done is like the actual reference to it in the code. It was probably going to blow up somewhere. Let's just get rid of it. We don't need it anymore. TFO. This is all junk. Actually, there's like a whole bunch of stuff, like everything below that I'm like still keeping around. Yeah, everything below this is junk. I could just nuke it, but we're not quite there yet. So one thing I don't like about version control is like how it's actually kind of hard to like, if you wanted to go and try to find stuff in old, like you can, you know, sure, you've got stuff and you've got commits and you got all the history and it's like you can wind it back to any point in time, like, but it's really difficult to, like if I wanted to find like a particular function, you know, particular method, whatever you want to call it, and like maybe it was renamed, like maybe like it's not the same, you know, there's no sort of like semantic search. So it's like, yeah, you've got it all, but like it's freaking like, when's the last time you've ever like gone and dug something out of an old commit? Like, you know, I've heard people complain, it's like, oh, like why do you just like leave code, comment it out? It's like, yeah, I leave it there because it's a freaking pain in the ass to go back and get it. That's why. You know, so it's like if I have code that's like, I haven't decided that I'm going to nuke it yet. It's not like it's taking up any more space, like in the version control. If anything, the diff across the thing will add the space when you remove it. But anyway, I digress. Actually, like this is sort of what I need to go and look at now. This like the param stuff. Like, so I went and I made this parameter registry thing. Let's like look at that. Actually, we can just go to. Where do I want to go to that? Ruby gems, params. Look at that. It's right there. Oh, that's weird. I guess there's like, you need the documents in the actual. Doc.info, gems, params, registry. Anyway. So we got to get the thing that like pulls the stuff. You know, the other thing that I might be able to do, pulls the stuff out of the graph and puts it into a memory structure. Like I did design this so that that I absolutely could organize it in terms of like parameter, sorry, like these parameter groups. So everything in the parameter registry has like the canonical identifier, which could be anything, and then the slug, which is usually like a symbol. And I mean, it can even have like multiple slugs. And so sorry, got a message. Not that anybody's looking, nobody's watching. Oh my God. How long has this been on? U1 SO. U1 SO. U1 SO. There we go. Anyway. So one thing I could do, and I haven't, like I designed this for this purpose, was I can actually subclass params registry and add in the graph stuff. And also I could subclass, well, maybe I wouldn't. I was going to say I could subclass the group stuff too, because that's I designed it, yeah, quasi-static methods to override in subclasses. So I could actually make the params registry actually just be the transform parameters, and I'm trying to decide if that's a good idea or a stupid idea. We could say subclassing the parameters would afford, or subclassing params registry would be potentially tidy, but it could be a premature optimization. But like it would afford, so what I could do is I could like roll the like configure stuff into the graph, or into the thingamajig, the subclass. So I would make like an intertwingler, params or something like that. Although, like, going that much farther, just like, I can't remember if the instance, is that no, it doesn't. So the instance, like, you have the registry contains templates. You feed it input, it will return an instance. So either that or it'll cack on you. I'm thinking I'm going to go to 2 hours. Just FYI, I don't let anybody's watching, but that's going to take me to like 5:30. Anyway, so like parameter groups are effectively isomorphic to where are we here? They are the same things. Well, you have a parameter list. This should be a union. Otherwise, it implies that RDF nil is this is one thing that's like really kind of a pain in the ass of like doing executable specs like these, or whatever you want to call it, sort of machine actionable specs, is that doing it in RDFA, real pain in the ass to like represent these things in nice markup. Okay, anyway. I've like bit the absolute shit out of the inside of my mouth, which is unfortunate. I'm not really too sure how I do that though, because it's not like I don't like grit or clench my teeth so much anymore. Maybe I like, yeah, whatever. So, so I guess we haven't done that. Like we haven't loaded up the cues, and we haven't. Yeah, so we've got to like. The thing about the cues. If I just go back to the. So like. When you load, so like, let's say you load the cues. So, cue. The thing about the cues is the cues contain transforms. T1, T2, God, learn to type, spell, whatever. T3, whatever. These will have implementations. I1, or they will be handlers. So we'll just call them handlet. H1, H2, so handlers, which themselves could have cues. So they could like, and so the structure that you need for loading, and then of course, these have parameters. And so, yeah, it's gonna like potentially go around and around and around a bunch of times. And of course, if it hits a cycle, it's gotta like not hit a cycle. Oops. Yeah, anyway. I'm like getting hungry, dog. Anyway, yeah, I'm gonna be hungry. Nobody's watching, so I'm gonna call it. Boop, boop, boop. MX, my OBS, stop stream.